Okay, question 5. Anna looks after a forest of Scots pine trees. Never heard of them in my life. Anna wants to be honest, how much is she earning through looking after them? Or has she acquired the land through some sort of family? I don't even know. Sometimes these questions drive me mad. Anyway, she wants to estimate the mean height, as you do, of trees in the forest. Work out the best estimate for the population mean. So we're just going to work out the total of all of it and then work out the mean from there. So we're going to multiply across. So 10 times 1 or 16.8, 168, 276, and then 79.5. We're then going to add them together and add up the total number of trees that are in this sample. So adding all them up together, we get 523.5. And then 523.5 is divided by 30, and that gives us 17.45. Fantastic. Okay, on to part B. Part B, we spoke about how we go into finding the equation of a regression line earlier in the paper. If you missed that video, it's question 3. You are using exactly the same steps that I've pushed, but where you get on the screen, you get like a value for A and a value for B, you'll get a value for R, and R will describe the strength of a correlation. So the strength of the correlation is a number that's between 1 to -1. And the closer it is to 1 means it's as strong as it can be to being the strongest possible correlation ever, and as close to -1, the strongest negative correlation ever. Okay, having a look at these questions here, and I've just realised I've spoken all about that, and actually that's for part C. So we'll go to part C next, because these ones don't actually matter. I'm going to copy this down and bring it down for part C. Because what you're effectively doing for part C, it says the table shows the diameter, height, and age of each tree in Anna's sample. Anna wants to use the diameter of a tree to estimate either its height or its age. Which of these estimates is likely to be more reliable? So is it working out diameter to height, or is it diameter to age? And what you do is you put in your diameters and your heights into your calculator and work out the R value. And then you do diameter and age in your calculator and then work out that R value. So here's one I prepared earlier. The diameter to the height, let me just check my notes, was an R of 0.899366761. I always write the whole number out. The diameter to the age, the R value is 0.81842588, and therefore we can say that her diameter to height is more reliable, and that's what should be used. Apologies for going the other way around. We'll go back to 5B now. Luckily they're not connected, you don't need one part for the other. So each tree in the forest is numbered. Trees numbered from 001 to 225 are between 20 and 40 years old. Anna wants to choose a sample of 10 of these trees at random. To do this, she uses a 3-digit random number. Complete the table below to show the number of each tree in Anna's sample. Oh, blimey. Wish I'd have known this sooner about 225. Makes a lot of sense now. I worked this out the hard way. So I was doing a subtraction. So 0, 1 take the other, 675, 450. That was 0. This next one, 450, 675, 450. And then I worked out, oh, look, there's a pan here. Yeah, 225. 225 is the magic number. So, yeah, shocker. Anyway, that means that the first number that we're going to have in here is 050. And when we get to, say, number 226, that's going to be number 1. 227 is going to be number 2. 228 is going to be number 3. So, effectively, you subtract 225 and you keep doing it until you get a number between 0 and 225. So, 425 take away 225 gave us the number of 200. Lovely. I'm going to use my calculator this next bit. 662. If anything, I've learnt a lesson about reading questions carefully. So 662 take away 225 gives us 437. That's not there yet. So 437 take away 225 is 212, and that means that is going to be the number that we use for 5B for that last one. Is that all of 5? Yeah, that's all of 5. Super. Sorry for doing them in the wrong order. Got excited talking about the correlation, the regression line, and its correlation. So yeah, who wouldn't get excited by that? Anyway, good luck for your exams. Keep liking, keep sharing the channel, and I'll see you at question 6.